When sealing such optical components, you can use different approaches. You can use adhesive, you can do soldering, or you can do welding. And we especially are using laser welding. If you want to find out why and how it works, stick around. Our components have certain requirements. One of them being hermetically sealed. And as per definition, all organic material is not capable of sealing something hermetically. It's due to the diffusion in the material. We cannot use adhesives. A second option, at least theoretically, would be soldering. But soldering has the disadvantage that more or less the whole component has to be heated up to a high temperature. And as you remember, we have an optical component inside, or optical setup inside, which is aligned precisely. There's a certain risk that there can be some deviation from the ideal position. So we use welding, especially laser welding. You might know stick welding, traditional welding, but it's obvious that the electrode would be much too large and we would melt the whole component. So this doesn't make sense. And even if we go to, for example, TIG welding, this would be too large to do a very good welding seam here on the component. The laser welding has the big advantage. There is only a very small region where all the heat is, or all the energy is deposited. It's only in the region of the welding seam. And as you might remember, welding means I have two parts from the same material. It's heated up to the melting point and that it's melting together. So you have kind of bulk material. A second advantage of the laser welding is that it's quite easy to automate. Yeah? And if you now want to see how it is actually done, let's go downstairs to the laser welding machine. Here is our actual laser welding machine. It's a quite large machine to produce or to process those tiny little components. And if we take a closer look inside the machine, here's a rotational unit. This rotational unit is used to do it automatically, the process. And we have the shielding gas from the backside. We're using argon. And more or less that's it. So I think we can close the front door and then the process can start. By the way, here's the display. On this display, it's the view directly with the laser beam. So you can see the same what the laser beam can see and what happens in the process. So let's start. The process itself is quite fast, and you can see there are a little dot. This means it's a pulsed laser beam, which is used, and this helps, for example, to not put too much energy into the welding seam, so the component doesn't heat up too much. So that's it. We're done with the process, and the component now can process with the next steps. By the way, I mentioned that we need those little tiny spots for the laser welding because our components are small. We have such components as well. Those are used for high pressure undersea applications, for example, in remote operated vehicles. And so they have to withstand 500 bars or even more. And as you can see here, the laser welding seam is much larger. I hope you learned something today. If so, please leave a comment or give us some questions for the next topics, and see you in one of the next videos. Bye bye.